Hello everyone, I would like to share some of my learnings on OWE. So without delay, let's get into the video. Nowadays, the public Wi-Fi networks are available in various public places like airports, shopping malls, railway stations, and many more places. Most of these Wi-Fi networks adopt the open authentication mode to allow the user to connect and access the networks without using any passwords. Since these open networks are transparent and unencrypted, there is a lot of scope for the attackers to listen on the data transmission process and can easily intercept the user's data. So, in order to resolve these insecure data transmissions that are caused by the open network, OWE is introduced. In 2018, Wi-Fi Alliance released WPA3 to resolve the insecure data transmissions that are caused by the open authentications. WPA3 provides the enhanced open, that is OWE. Just like the open authentication, anyone can able to connect to this network and access it without using any passwords. The main advantage of this feature is it will encrypt the data using Diffie-Hellman key exchange algorithm, which will resolve the insecure data transmissions. As I already mentioned, OWE will use the Diffie-Hellman key exchange algorithm to encrypt the data. Let's see what is meant by Diffie-Hellman key exchange algorithm. As we all know that encrypted channels maintain both confidentiality and the integrity of the transmitted data. The exchange of secret keys has always been a hardest task. So exchanging the encryption and the decryption key always needed a safe approach. In order to highlight this issue, I am taking the example of two users and both the users want to communicate with each other in safe and a secure manner using the encrypted messages. To be able to send the encrypted messages, an encryption or decryption key must be formulated. Sending this key directly makes it easier for the hackers to capture the data since they don't have a secure channel to communicate. Anyone looking at this communication channel can easily intercept this key. If this key is intercepted, then all the messages between the users can read by any malicious actors, since they already have the decryption key with them. So this is where the Diffie-Hellman key exchange algorithm comes into the play. Diffie-Hellman key exchange is an algorithm that will helps to exchange the cryptographic keys over the insecure channel without even compromising the security and the integrity of the transmitted data. It is developed in 1976 by Whitefield Diffie and the Martin Hellman. It will establish a secure channel for the communication. Now let's take a look on how it works. In order to understand this concept, I'm using a basic color theory. Initially, I'm considering two users, Sophia and the James, and both the users must have their private color set and it should not be made public. That means which is known only to them. Let's say the first user's private color is blue and the second user's private color is orange. They should be having a common public color and which can be decided over the insecure private channels if it is needed. In this case, choosing the common public color as yellow. Now both the users should mix their common public color with the private color. Similar here, the Sophia is mixing her private key with the public key. Then she is going to get a new color, mixed color. So here green is the new mixed color of the Sophia. Now she has to send this mixed key to the James. Similarly, James has to mix his private key with the public key. Then he is going to get a new mixed key. Now he has to send that to Sophia. This is done over the insecure channel, which means this communication can easily be intercepted by any malicious actors who are listening to the channel. Even if the malicious actor got that he has only that mixture, but he can't possess what the individual private colors that both the users selected. Once after the mixtures are received, they should suppose it to mix their own private color with the mixture color received from the opposite user. Then both the users going to get a final key. that can be selected as the final secret color or the final secret key. Even though this entire communication takes place over an insecure channel because of inability of the hacker to receive the private colors of both the users, and he has no idea that the secret color in the case of transmission is actually brown, blue or orange or which color. Let's take a look on the mathematical side of Diffie-Hellman key exchange algorithm. To explain this, again I am considering the two users, Sophia and the chains. Here, without using the colors, we are using the actual mathematical parameters to describe the private key and the public keys. Here, the private keys of both the users can be denoted by XA and XE, and both XA and XE should less than Q, where Q is a prime number. And the public key of users will be YA equals to alpha power XA mod Q, where alpha is a primitive root of Q. Here it can be calculated, so public key can be calculated by using this formula. So now both the users should mix their private key with the public key. After mixing, they are going to get a new mixed key. Now they have to send that new mixed key to each other. After that, they have to mix their own private key with the public mixed key that is received from the opposite user. Then both the user will going to get a common final key, and it can be calculated by using the formula k equals to ye power xa mod q. So here k is the final key. Let's come back to the OWE. In OWE, it has two modes. First one is OW authentication and second one is OW transition mode. So let's first discuss about the OW authentication mode. In the OW authentication mode, it will involve the two steps. First step is OW discovery. Here I am assuming the communication between a station and the AP. Now the station will send an authentication request to the AP in OW discovery mode. Then after the station success in OW authentication, AP returns the authentication result to the client. In the authentication result, it contains the AKM field, that means auth key management field. It will notify whether the station is capable of OWE or not. After receiving the authentication result, the station enters the OW association phase if it supports the OW authentication. Step 2. OW association. In this, the station sends the association request to the AP which contain the public key of the station in Diffie-Hellman parameter. After that, AP returns the association result to the station which contain the public key of the AP in Diffie-Hellman parameter. After the public key exchange between the station and the AP is completed, then the pairwise master key will be generated. That is the final key for the communication. After that, the station will perform the four-way handshake to determine the key that is used for the communication. In OW authentication, the client which is capable of OWE can able to connect to this network. Otherwise, the AP will deny that client. That means if any client which is not capable of OW authentication, it will disconnect that client. The AP will disconnect that client. Now let's see how to configure the OW authentication mode. The configuring of OW authentication mode is pretty simple. Just we have to fix the value of OWE to the prototype. And in order to enable the management protection frames, we have to fix the value required to IEEE 802.11w. Here it is the simple and sample configuration example that I am using to configure the OWE in my AP. Till now we discussed about the OWE through the theoretical way, but now let's see how it works in the practical world. To explain the OWE in the practical way, I am using the Candela India product LandForge. So LandForge is a product on which we can able to create number of virtual stations which can act similar to the real clients. So this is the GUI of our LANForge. Here we can see the Wi-Fi 0 from the Wi-Fi 5. These are the radios on which we can able to create the virtual stations. Now let's see what is the configuration that we configured in the AP. This is the CLI of AP. By giving the IW info command, we can check what are the SSIDs that are present in the AP. And we can also see all these SSIDs are capable of OWE authentic association mode. Now let's come back to the LANForge manager. Now select any one of the radio and create a station. Now here I will going to show how to create a station. Now click on create. Now click on Wi-Fi station. Give any random ID to the station ID. Now click on DHCP. Here I am enabling the DHCP so that the station will going to get an IP after once it get associated with the AP. Now click on Wi-Fi settings. Give the SSID that we configured in the AP. As I already said, it is the part of WPA3. Now enable the WPA3. Now click on apply. So this is the station that we created just now. Now double click on the station. Go to advanced configurations. Enable the advanced 802.11w. Under key management select OWE and IEEE 802.11 should be equals to required. Here what we are doing means we are creating a station which is capable of OWE. Now click on apply and then OK. Now we created the station which is capable of OWE. The station is disconnected, so I am trying to connect the station again. It will take few seconds for the station to get connected. Yes, the station got IP. That means the station is associated. Again, I'm disconnecting the station and trying to sniff the packets on the radio on which the station is created. So this is the sniffer. Again, I'm coming back to the station. I'm connecting it back. Why I'm doing this is we can able to see the packets from the starting while the station is connecting. The station got IP. Go back to the sniffer and stop the sniffer. This is the packet captures that we collected on our particular station. So these are all the frames, different kinds of the frames. As we can see a lot of beacon frames here. And we can also see probe request, probe frames, association, authentication request, responses, and four-way handshake also. Now click on probe request. Now click on wireless management. Under that, click on tag the parameters. Now here we can able to see the RSN information. Now click on it. Under the auth key management, now we have to see whether the client is capable of OWE or not. Yes, it is capable of OWE because it is indicating that. Now click on RSN capabilities. Here, management frame protection required and management frame protection capable should always be equal to true. Now click on any one of the association frames. Now click on beacon frame and let's see what is the information present in beacon frame. So whatever the information we found in probe request or the probe response, the similar kind of information we can also find in beacon response. And in additional to, in the tagged parameters, that is SSID parameter set, we can also find what is the SSID to which it is connected with. Under the tag parameters, we can see the RSN information, and under that we can see the auth key management and RSN capabilities and everything. Now let's see what is there in the association request or the association response strings. Now click on association request, and here we can see the same kind of information that we found in probe request and the beacon frames. But in additional to, we can also find the Diffie-Hellman parameter also. The same kind of information like auth key management and everything, and management frame protection and the capabilities. In additional to that, we can also find the Diffie-Hellman parameter. Under that, we can able to see the public key that is selected commonly for both AP and the station. And we can also see the four-way handshake done by the station in order to determine the key that is used for the communication. So this is all about the OW authentication process. As I already mentioned, OW authentication process connects the clients which are capable of OWE, and it will disconnect the clients which are not capable of OWE. And what if any clients which are capable of OWE? Yes, there are a lot of clients which are not capable of OWE. Presently, in currently, iOS devices are not capable of OWE. So what will happen? Then AP will disconnect that kind of clients. So in order, this is a big problem, right? So in order to avoid this problem, there is another mode in the OWE. That is the second mode, that is OWE transition. Let's see what is OWE transition and how it will work. So OW transition mode is the another mode that will allow the OW capable stations to access the networks in the OW authentication mode, and it will allow the non-OW capable stations to access the networks in the open mode. Here it will create the two SSIDs, for example SSID 1 and the SSID 2. Out of the two SSIDs, one SSID will be broadcasted and the one will be hidden. For example, SSID 1 is broadcasted, then SSID 2 will be hidden. That means it is not visible to anyone. In the SSID 1, it will carries the OWO transition mode element, but the hidden element, hidden SSID, that is SSID 2, will carries the information. So this is how it will protect the information. So this is how it will protect the information from the hackers. Now let's see how to configure OW transition mode. Just like the OW authentication mode, transition mode is also very simple. Just we have to fix the value OW transition to the prototype. And in order to enable the management frames, we have to fix the value required to IEEE 802 point level. Here is the sample configuration that I used to configure the OW transition mode in my AP. Now let's see how WE will work in the practical world. In order to explain this concept, again I'm using our Candela technology product LANForge. So this is the LANForge GUI. Here I created two stations, and one station is not capable of OWE. That means it will directly connect to the open network just like the normal things. So another station is capable of OWE. Now let's see how it will work and how two SSIDs will be created and how the SSID will be hidden and the other SSID will be broadcasted. I already created and taken the packet capture on the station which is capable of OWE, and let's see how it will work. So this is the packet capture that I took. Here Just click on any beacon response and we can see what is the information that it is present. Now click on wireless management. Click on tagged parameters and we can find the RSN information. Click on SSID parameter list. Here we can see what is the SSID and what is the SSID created and to which we connected to. Now click on a beacon frame. Now we can see the same thing, but here we can see something. Under the tagged parameters, under the SSID parameter set, we can't see any information related to the SSIDs that we connected to. Here we can see empty information regarding the SSIDs. And we can see everything which is similar to the other frames. Like OK management is set to OWE and RSN capabilities management protection frames should be capable and required. Everything is same. But there is a slight difference. That is, in the SSID parameter set, we can't see any information that is related to the SSIDs. That means it is displaying the information which is related to the hidden SSID. That's why the information is not visible to anyone. So on this SSID, the information will be carried. Here we can see SSID wildcard and the SSID open Wi-Fi. So one SSID will be broadcast and the another SSID will be hidden. Now click on association request and let's check what are the information present in the association request. The same kind of information will be present in the association request, but in addition to we can also find the Diffie-Hellman parameter element. Under the Diffie-Hellman parameter element, we can also see the public key that is generated commonly for both AP and the station. And we can see the similar information that is OTKey management protection frames and everything. And here we can also see the four-way handshake and it is performed by a station to determine the key that is used for the communication. So this is how the OW transition mode will work. Here it will broadcast one SSID and the another SSID will be hidden. The hidden SSID will actually carry the information. So as it is hidden, no one can able to see what is the information which is present in that. And the users can't even know that the second SSID is there and it is hidden and it is carrying the actual information. So this is how OW transition mode is working. Thank you for your valuable time.